Josie, and this is Carolina, and we're going to talk to you today about the ozone cycle and the greenhouse gas effect. Before we go through the mechanism of ozone, I just wanted to talk a little bit about what it protects us from, and that is ultraviolet light. As you can see in the spectrum here, ultraviolet light has got shorter wavelengths than visible light or infrared on the light spectrum, and that means that it has more energy. UV light from the sun splits diatomic oxygen into monatomic oxygen, which is very unstable, but it has zero formal charge. And then what happens is diatomic oxygen reacts with monatomic oxygen to form ozone. And now ozone has two resonance structures which make it more stable than these two independent molecules. And here are the two resonance structures. And then the UV light from the sun can also cleave this bond in ozone to form monatomic oxygen and diatomic oxygen. That monatomic oxygen can then react with ozone in a concerted mechanism to form two molecules of diatomic oxygen. And thus the cycle begins again. So when the sun gives off heat, one of the forms that it gives it off in is visible light. And visible light has a shorter wavelength than infrared, as we saw in the spectrum. So carbon dioxide and all the other greenhouse gases are visible to infrared light, meaning they absorb it. And so when visible light comes and it hits the earth, it is partially absorbed by the earth, but it's partially reflected. And when it's reflected, it has a larger wavelength, which makes it infrared light. And so it'll come off in a larger wavelength, which is then absorbed by the clouds of carbon dioxide, methane, and water vapor. So when the atmosphere then absorbs the reflected heat off the earth in the form of infrared light, that's what creates the heat shield that is the greenhouse gas effect.
So contrary to popular belief, it is actually water vapor and not carbon dioxide that is the main contributor to the greenhouse gas effect in Earth's atmosphere. And this is simply because there's just more water vapor by percentage than there is carbon dioxide in the atmosphere. The reason why we focus so much on carbon dioxide when it comes to talking about the greenhouse gas effect and global warming is because it is much easier to control. And it's a much smaller percentage, which means we can actually have an influence on it, whereas water vapor we can't control that much. So historically, there's been a great rise in carbon dioxide emissions in the atmosphere, starting all the way back with the Industrial Revolution. And in addition to that, there's a slight environmental shift that goes on as the seasons change, because during the summer, when there are more trees, and there are more trees in the northern hemisphere, those trees can then absorb the carbon dioxide, and the levels in the atmosphere obviously would decrease. So, surprisingly enough, the greenhouse gases comprise a really small percentage of the Earth's atmosphere. Nitrogen is 76.5%, oxygen is 20.5%, argon itself is 1%, but water vapor, carbon dioxide, and other gases comprise 2 or less than 2% of the entire Earth's atmosphere. And shockingly, that corresponds to about 33 degrees Celsius change in the temperature of the Earth. So without these gases in our atmosphere, the Earth's temperature would be about 33 degrees Celsius or 60 degrees Fahrenheit colder. And a fun fact is that on Venus, 96.5% of the atmosphere is comprised of carbon dioxide, and that corresponds to a whopping 389 degrees Celsius change in temperature.
Why it matters. So the greenhouse gas effect is extremely important because the Earth does need to be heated in order to sustain the life that we have. But if through our human production of CO2 we increase the temperature of the Earth, that can have detrimental effects on some naturally occurring cycles, such as the weather, the climate, and they could melt ice caps, which could have overarching effects that we could not even account for. For the ozone cycle, it's extremely important that the amount of UV rays that are getting to the Earth's surface are reduced, because the direct UV exposure to our skin can have detrimental effects to our bodies, because they can mutate the genes in some of our cells and cause cancer. And we don't want that. We want to be able to go out in the sun. And finally, the one thing that we can do to control and to help control both these cycles is through government policy. And for example, with ozone, that's been extremely helpful in cutting down CFCs, which decompose ozone. And for example, we need to cut down on our CO2 levels, and you can do that through laws. And so hopefully with this knowledge, we can keep our environment safe and sound and happy for the future.